Okay. Hey, it's a pleasure to welcome you all today to today's discussion. We're going to talk a little bit about a collaboration we've undertaken between Ampere Computing and AMI. And this has just been a tremendous technical collaboration at various levels of the software stack. Though today we really wanted to kind of focus specifically delving deeper and showing some practical examples of where the AMI Data Center Manager can be used to highlight Ampere specific platform capabilities and benefits. So we know your time is valuable. And so for this brief tour today, on the next slide, we're really only going to cover 5 things. The computing partnership we've got, I'll speak a little bit about Ampere's approach to cloud native workloads and the design principles behind our products. I'll turn it over to my partner in crime, Zach, to talk about AMI's Data Center Manager and the overview, features and benefits therein. And then we'll wrap it up with what's next from the partnership. So I'll be one of your hosts today. If you want to click to the next, my name is Pete Baker, and I work at Ampere Computing, running the Customer Developer Engineering Group. We represent the software developers, the SREs, the DevOps engineers, the people with hands on keyboards advocating not only for designing the world's best microprocessors, but doing so in a way that provides you the performance and capabilities that you want, but also the ecosystem and ease of use that you need. So in my experience over 30 years in the semiconductor and software business, I found that it's this marriage of hardware and software expertise that really propels breakthroughs. Here at Ampere, we're hard at work building the hardware, though we know that the great hardware can only be made even better by ensuring easy, robust tools work on it. And that's where this collaboration with AMI and their Data Center Manager tool was born. My partner today on the right is Zach Bobroff. He's the Chief Product Officer at AMI, and he leads the strategy, product development, go-to-market for their products. Now, if you're not familiar with AMI, they focus more on solutions for the data centers, servers, and really technology infrastructure across that board. And they have terrific emphasis on security and manageability. So on the next slide, let's spend a few minutes familiarizing you with Ampere. So Ampere, we're a modern semiconductor company. We believe we're reinventing the way CPUs are designed and constructing what we call the first cloud-native processors. We've embraced an efficient multi-core design philosophy, resulting in processor architectures that deliver better power efficiency compared to historical legacy designs and remove a bunch of the design baggage that came with it. For many of you who are frequent users of our products already, thank you. And for those of you who may be here learning about us for the first time, you're very welcome. Why might you consider Ampere instances? Well, there's really 4 distinct advantages. We've got a cloud-up native design. We built these based on our experience with customers working on all kinds of cloud workloads, from web services to data science, machine learning, and of course, artificial intelligence. Our designs deliver high numbers of physical cores to be leveraged by software to scale up and scale out. And in our case, each vCPU is a full CPU. Every core is a real core. Because of that, each instance is more efficient and can do more work and minimize noisy neighbors. And this allows us to provide more predictable performance across the board. And all of that translates into a design that offers high efficiency while reducing the energy consumption. And often that translates, of course, into cost and allows customers to meet really important carbon emissions targets and cost targets they may have. So it's not just one product. On the next slide, we'll show we're building a robust roadmap to address needs across the spectrum. So we emphasize creating really an open and interoperable environment, allowing users access to affordable technologies and mix and match components as they see fit, and develop their own accelerator products and services on top. So kind of working from the bottom up here, starting with the Ultra and Ultra Max entrants, this is our most efficient product family for modern compute environments, really looking from the edge all the way to on-premise, all the way through the cloud. And then looking ahead, we've shared our extended roadmap, including our current generation of products we call Ampere 1. This family of processors has a collection of custom IP for compute environments, which includes a high-performance mesh, die-to-die interconnect. We've improved the power efficiency. We've added 12-channel DDR5 support. And for you infrastructure folks, this is all intended for an air-cooled environment. In addition to that, we proudly shared that future generations of Ampere servers are expected to feature higher core counts, all the way up to 512 cores. And we're applying that same innovative approach from Ampere 1 CPUs to what we call Ampere 1 Aurora. which is incorporating Ampere artificial intelligence intellectual property. This integrated product represents really a revolutionary advancement, and we're excited about the potential of the full product portfolio. So as we think about this, we appreciate that as you designing mixed architectures in your support matrix, that adds a lot of complexity. You're talking about scaling on demand, hybrid environments, non-homogeneous architectures, and a whole bunch of various accelerators that may be introduced into the fleet. And that can be a daunting task, regardless of where you're set in the support structure. And that's where Ampere's collaboration with AMI can ease some of that pain. So at this point, let me turn it over to Zach and let him walk through what AMI's views on the data center manager.
Thanks, Pete. The Ampere 1 and Ultra family look really exciting for the industry. That high core count and extreme focus on the things that the customers are looking for should shine through. But if we look at AMI for a moment to give you a brief introduction to that, most people are probably familiar with AMI being a firmware company. It's actually our 40th anniversary this year. And we are known for our Aptio product, for our boot firmware, our MegaRack product for our manageability, and Tectagon now for our security firmware. But what we're here to talk about are actually those premium services or middleware layer on top of it that provides management services. That's what we're going to talk about here for the most part. This has been developed through a lot of our collaboration and know-how through working with hyperscalers and CSPs. And let's go forward and take a look at some of the growing pains that exist within the data center today. So there's a lot of text on this slide. What we want to talk about is that how do you scale to match demanding needs today? Because you've got to grow up your scale on demand. You're going to have hybrid environments now. Those are the norm. You're going to have public cloud, private cloud, and on-premise. You've got a heterogeneous hardware vendors and silicon vendors now. And also adding to the mix are all of these additional compute units. GPUs are obviously the most common ones today. Smart NICs are also coming into play. So how do you manage these growing needs while reducing costs and ensuring the sustainability of your overall data center footprint? So AMI Data Center Manager, or DCM, is the tool we've developed to match those needs. It's a powerful solution. It's basically designed to work on-premise. You can run it from the cloud if you want as well, but it is a compute-intensive thing that talks to all of the servers. So it's going to get telemetry information across all of your systems for all the devices in there with CPUs, GPUs, hard drive, RAM, as it talks about there. It's basically your single pane of glass that aggregates all this information for all the servers in your data center and allows you to see them granularly and holistically in a device-centric way. DCM is also importantly an agentless solution. So this will work if there's no operating systems on there. It will work as you roll new devices in or re-image them. You don't need to install anything there to have this running. It also leaves no customer data being leaked to the cloud because of its on-premise capability. DCM can also be consumed in other ways. As you see in these pictures on the left there at the bottom, you see the web console that if you want to use that. But if people want to integrate it with other solutions, it's also got a Kafka producer to dump all of the data it's consuming there. It's also got RESTful APIs if you just want to use it, all the data that is within this data lake in your own applications. And if you want to use some of the iframe capabilities, you can embed it in your own solution as well. So this makes DCM a very flexible solution to integrate whatever your management needs may be. So if we talk about data center management solutions today, you've got kind of three different categories here of DCIM solutions, server management solutions, and workload and cluster management solutions. DCM isn't exactly a replacement for any one of these tools. It's almost a complementary solution that brings them all together. So your DCIM or data center infrastructure management solutions, sometimes building management solutions, they focus more on the infrastructure of your facility, not as much on the devices within them. Server management solutions, they tend to be developed for specific OEM platforms, and workload and cluster management solutions tend to only care about how to properly distribute the workloads amongst the systems there. So DCM kind of combines elements of all of these and integrates with each one of these types of solutions as well to provide a complete solution to match today's demanding needs. So the real question we've talked about it being agentless. How does this work, right? So you've got your servers that are all sitting there throughout the data center. Most of those will have a BMC on them. And then through the BMC, either over IPMI and or Redfish, we're going to pull all the information from them. If the systems don't have the BMC on the platform, we can also fall back to pulling some information via SSH to them. And not everything in your data center is a compute system, right? You might have PDUs for power, you might have storage systems, you might have networking devices like your switches, and you might have cooling devices such as CDUs. So DCM also goes out over SNMP or more commonly today, Redfish to talk to all of these devices and pulls it all together. Now, the nice thing about these interfaces that we're talking about is they're all industry standard, and it provides an end-to-end rack capability to see all of the devices in your rack. And again, back to that single pane of glass view, you've now got it all aggregated into one location, and it's truly unique to be able to see it all in one place. If we talk about some of the use cases here, and we're going to see these in the demo coming up, you've got heterogeneous and vendor agnostic device support like we're talking about. You've also got detecting real-time power, thermal, and health issues throughout all of the systems in your data center. One of the other interesting features is you've got tons of devices in your data center. How do you actually know the firmware versions that are running on the various components in there, and how do you manage that and update that at the same time? One of the other key things facing data centers today is with the advent of AI that's going into these systems, the infrastructure or cooling behind these AI systems continues to evolve, and we want to make sure that this solution provides the infrastructure to manage not only the GPUs themselves, but also that infrastructure that drives the use of those AI components as well. If we look at some of the latest key features for DCM, obviously GPU support was one of the key features, but the most important support that we've added now is the Ampere support for the latest servers that we are collaborating with them on. So Ampere, even if you have those NVIDIA GPUs in that Ampere system, you're able to manage all that, and we'll see it all in the demo as well. It's also got real-time PUE monitoring. The liquid cooling support, we've expanded upon that from the limited CDU support we had before to expanded CDUs. We've also got a tiered feature-based licensing now. So we've run into customers that are like, I like your tool, but I don't need all of the features. I only need one level of the features. So we've now added an ability to lower the cost of entry so that those customers can come in and use the tool without having to pay for features that they're not looking for. Let's take a look at the demo now. So first thing, you come to a console, tons of information on here from the amount of electricity you're using, the amount of renewable you're using, all of the systems that are under management, the temperature average throughout the data center, all the events going on, inventory changes, total power usage, and everything like this that's going on throughout your data center. You can also see the number of rooms, racks, and devices that you have. And if we look at that, you now can break down the hierarchy that I want to look at a specific room and a specific rack that has Ampere servers in here. We can look at Gigabyte up the top. So the Gigabyte server here, first thing we want to double check on is what CPU is it actually running from the system inventory. So you can see here it's an Ampere Ultra Max processor, 128 cores, running at 3 gigahertz. Also, you can look at some of the system firmware that's running on here, all of the different system firmware, not only the BIOS and the BMC, but what other firmware there was. You can look at the storage devices here, the memories that are in the system. It collects all of this information out of band so that you can properly use it. We also flow down to the GPUs, the power and temperature throughout the history, and all of this is customizable too so that you can view this however you want. You can also see the GPU power and temperature that's going on. So how has the GPU been performing? How has it been utilized? You can also see all of the different SSDs in the system, everything like that going on. And you can also see other various information on the systems. And it also shows you the health status of all these components at the same time, so you can feel comfortable that it's executing properly. Now, if we switch to another system, the information is going to be very similar, just different manufacturer. It's going to have various inventory information again, health status across the different devices. You can see this one had all healthy components, power and temperature again, the different GPUs in the system and how they're functioning. You can see the events again, everything like that. If we want to go up a level, now we can actually view it at the rack level. These three systems are in the rack. You can now view the aggregated information of everything that's in the rack. How is the power performing across all of these systems, and how is it aggregating up as you sum these three systems together? Facility power, other information in here, all the aggregated events. It's very useful to be able to see it not only at the node level, but also at that rack level, that room level, that row level, so that you can see where the power is being used and how efficient these systems are being run. If we take a look at another location, we look at the devices now. You can see here's all the devices. Here's how we've grouped the devices. So I can also create logical groups of the Ampere servers. So even if they're not on the same rack, I can still aggregate the information across them so that if I care about groups of Ampere servers that may be intermixed, I can also do that. If I look at my sustainability information, it shows me here, here's how I'm tracking as far as my carbon output is going based upon my power consumption. How is it projected to grow and how is it comparing? You can also edit thresholds here so that if my data center is being too power consuming of carbon data, it will send notifications when it reaches certain limits on top of that. And that's the projection line that we're talking about here. It's viewing it as kind of an expanded flow of how it's been increasing over the past few months. Another important feature is some of the comparison data here. So you can compare two systems to see how they're performing. So if we go in here and we pick two different systems, one of them will be an Ampere. Actually, two different Ampere systems in this case. And how are they performing over the last hour, 24 hours, or we'll look at the last 24. And we'll show you basically how they're performing as far as power consumption and carbon output at the same time. Shows you the number of processors, all the different comparison of some of that static data, and how they're performing as far as carbon emissions go. What if comparisons are useful as well? That what if you want to replace one server with another one? Say you want to go with an x86 architecture and try to compare moving it to a Ampere server. So you can see here, whenever you pick an existing one here, it's just DCMI Microsoft, very nondescript. It gives you the idle power and the peak power of that system, how many of them I'm looking to replace, effective from April to going forward. I want to pick a IPMI gigabyte system, and I'll have to fill in some of the information of how we're going to say the power is going to be using. And these average numbers are currently NA just because we hadn't been running the tool long enough to give you a true average. But at the bottom now, it will tell you that the power consumption will be reduced by 34.59 megawatts in the next 3 months, and the carbon emissions similarly will decrease. We're using local power company information to get you some of that renewable and carbon information that would be actually affecting your power. Similarly, here's the cooling analysis. You've got basically what are your servers. Some are in the cold zone, some are in a hot zone. Most of them are actually in the middle, so you can actually do some analysis of why some of those servers are hotter than others. Here's also the average weekly energy savings you would have if you took one of these compute units out. So what is their basically energy usage and their monthly carbon output? Here's also all the reliability information. We're looking at CDUs at the moment. What are your failure indicators? So which systems are failing or which systems have failing components, so that you can try to diagnose if one system's failing more than others, this is clearly going to stand out for you. And you've got different failure types of system, component, and others. You've also got the ability to look at unhealthy thresholds. And if we go back to the dashboard again, this is again that up-leveled view of everything being included in one single view. So that was a very quick demo, but I hope everybody was able to keep up. At the same time, you don't only want this information, you want to see how this information is going to affect your wallet and see where the money really comes in, right? So we took some analysis here for a medium-sized data center with about 5,000 servers and 25 or 250 racks, which is about a 2 megawatt data center by today's standards. Maybe next year that will be a 2 gigawatt data center, but we'll look and see how the industry continues to evolve. But the first thing is you will have better management of your overall IT infrastructure. You'll be able to indicate failures, so you won't be replacing components before they fail. You'll also have some other information about being able to push firmware updates, so your IT assets can extend an extra year or two, depending upon your current usage. That can save you $4.5 million per year. You can also optimize rack density, so you can have a higher yield. Basically, you can put the systems in your rack to maximize the overall rack power usage, which will save you about 375K a year. You've also got the no need to have the smart PDUs because we're scraping all the information from the PDUs themselves. You also will have less downtime of your servers. You can schedule outages as opposed to them happening randomly based upon failing components. So this should save you on an average of $1.5 million a year. You're also going to be pushing streamlined firmware updates to all those systems, again, so that you can reduce outages. All of these things can be properly managed and scheduled. Can save you that 1.5 million as well. And then you've also got reduced cooling costs by safely increasing temperatures. With the keen analysis that you can get not only from the systems themselves, but when you aggregate that at a rack and row level, you can now properly see your hot and cold zones so that you can safely increase those temperatures and not overcool them as many people do today. And this can have an average savings of 340K a year. So when you add all this up, it starts to equal real big numbers of $10 million of annual potential savings per year. So using a tool like this pays for itself in the first year and every year after at the same time. Also, DCM has a pretty robust ecosystem behind it. AMI actually acquired this tool about 18 months ago or 2 years ago, and we are making it more like the Switzerland approach to the industry. So there's over 100 different data centers that do operate with this today. This ranges between enterprises, telco, fintech, HPC, CSPs, edge, all sorts of things. We've also got over 10 different OEMs and ODMs that resell and use this tool in a rebranded way. We're also used in over 20 ISV solutions. Those can be different DCIM vendors that package and include this, building management systems, IT asset management, which is one of the things that we tend not to really talk about as much. But this gives you keen inventory information across all of the devices in your system and gives you alerts when those things change. So it can be very highly integrated with a CMDB, so you can make sure you're only paying and you're properly paying for all of the IT asset systems that you have to have under maintenance agreements. Also, you've got 30 OEM and server vendors supported. So whether or not the hardware vendors are reselling it, we actually add support for over 30 plus OEM and ODM servers. And it is standards based, so it can work with any server as long as they're following the proper IPMI and Redfish standards. We support over 25 PDUs, UPSs, and CDU vendors as well, and over 15 network and storage vendors across the switches and the storage devices that exist. So a very robust ecosystem behind this. Now, one of the other things we want to talk about is the ongoing collaboration between AMI and Ampere. We want to continue support for Ampere 1. Obviously, as Pete was talking about, we want to continue to drive forward on all of those systems that they're coming out with, and very impressively 512 cores. Today, we also support managing Ampere servers, but we're adding support to also run on those Ampere servers. We're getting more creative in the deployments. We're looking at Docker-based deployments and others. We also want to add more advanced management capabilities to power cap Ampere servers, so that if you have a rack of servers and one of them starting to shoot up in its power usage, you could cap the surrounding ones so that during that spike, the rack doesn't go over power. We also want to be able to push firmware updates and orchestrate them more effectively on Ampere systems, so you can schedule it across various nodes throughout the day. We also want to have better workload management so that you can have workload aware power and dynamic resource management. So you know the workloads coming in to your orchestrator. How do you best then push it to the servers that are underutilized or are more adept at handling those? So we're working at creating some of those bridges to your various workload orchestrators. Some of the AMI resources you might want to check out to learn some more about DCM up front. Obviously, you can just go to our website that has access to all of our products. But if you want to drill down and look at DCM specifically, and one of the key things is we offer a free trial of DCM, and you can access the white papers too. So if you want to kick the tires, see how it works on your Ampere servers, by all means, go give it a shot. And then we've got our YouTube channel and our X platform as well right there. And if you want, feel free to reach out to us directly at dcmsales@ami.com. We're here to answer questions, help you get started on whatever your needs may be. Now, I will hand it back to my partner in crime, Pete, to go ahead and wrap it up.
Thanks, Zach. I'll respond in kind. If you want to get in touch with Ampere about our resources, we've got a terrific developer center with a ton of collateral, white papers, documents, etc., teaching you how to use the products. We've got a robust developer forum and community where you can come in and chat with others who are heading down the same paths of using the technology, and a variety of other channels to get in touch with us as well. We're looking forward to hearing from you. Lastly, I'd just like to say thank you for joining us today. Like at Ampere, we like to think we're just hyper focused on modernizing the data center, and it's terrific to be joined on that endeavor by companies like AMI. As Zach showed, there's real cost benefits to be realized by leveraging modern tools like their data center manager with our modern processors to manage and optimize your IT infrastructure. And that's going to maximize the value of on-prem cloud or AI compute, regardless of what you're doing. And all that's going to allow you to kind of reinvest in the innovation and sustainability that we're all looking to achieve. So we hope you found this session valuable and look forward to connecting with you in the future.